Hi everybody, welcome back. Hope you are doing well. And today we'll start a new chapter, the chemical formulae and equations. And this chapter is very interesting for me. And I love this chapter so much because this is the way how chemistry is going. Okay. And once you understand this chapter, it will be like a solution for the secret of the chemistry. Chemical formulae have three ways to be described or to be represented. We can describe a chemical formula in its empirical form or molecular formula or a structural formula. The empirical formula is the simplest form of the molecular formula. Molecular formula is a way to represent the formula where we can see the actual number and the type of atoms. A structure formula shows the actual number and the type of atoms and the bonds between these atoms. We will explain each type of these formulae in details. Let's have some keywords to remind you with. Chemical symbol is a letter or group of letters that represent an element in a chemical formula. Like, for example, oxygen. The chemical symbol of oxygen is O, one letter. Magnesium. The chemical symbol of magnesium is Mg, group of letters, and so on. You can see these symbols in the periodic table. Compound ions. Compound ion is an ion that is made up of different atoms, which are bound together by covalent bonds. All these atoms together have an overall charge. That's why it is called a compound or molecular ion. Some elements and their chemical symbol, silver, Ag, gold, Au, and so on. All of these symbols are in the periodic table. Molecular ions, like hydroxide ion, OH, which is composed of oxygen and hydrogen and an overall charge of -1. Ammonium, NH4, +1. Carbonate, CO3, -2. Sulfate, SO4, -2. And nitrate, NO3, -1. This is carbonate, CO3, -2. So it is composed of 3 oxygens and 1 carbon. The black is the carbon and the reds are oxygen. And the overall charge is -2. Why do you think it's -2? How the overall charge comes? The overall charge is the total charge of the whole compound ion. For example, we have CO3. The valency of C is 4. The outermost electron. And the valency of oxygen, every oxygen, is 2. It needs usually 2 more, it usually accepts 2 more electrons. Okay, so we have 3 oxygens, so 3 -2. In total, negative 6. So positive 4 minus 6 will be negative 2. This is a simple way that can describe how that overall a charge came. But you don't need to know that because as much as you use these ions, you will be familiar with their charges. So practicing in this chapter is the most important thing to practice as you can. To practice writing the formula, to practice equations when we come to equations. So when I give you homework here, it's very important because this homework will help you to remember what was this ion, what was its charge, and how they bound together. So it's very important to practice in this chapter. NO3 nitrate, 1 nitrogen and 3 oxygens with 1 negative charge. Ammonia, 1 nitrogen and 4 hydrogens with 1 positive charge. This is the structure of sulfate, SO4 negative 2, which has 1 sulfur and 4 oxygens and an overall charge of negative 2. A compound. How we name a compound. A compound can be a covalent or ionic compound. A compound can be equivalent or an ionic compound. Covalent compound is non-metal bound to another non-metal, while ionic compound is a metal bound to a non-metal. So how can we name ionic compounds? As ionic compound has a metal, we will start the name with that metal. So if the compound has a metal, we will start the name. We start with the name of that metal. And in the name, the valency will be indicated, which ion, which type of ion, because some metals have more than ion, like iron. Iron can be iron positive 2 or iron positive 3, iron 2 or iron 3. So iron can lose 2 or 3 electrons. If it loses 2 electrons, it will be iron 2. If it loses 3 electrons, it will be iron 3. Okay? So compounds that only contain 2 elements have an end, a suffix in the name called "ide", like sodium chloride, calcium bromide, magnesium nitride. Okay? And the important exception is hydroxide ion, because already hydroxide is an ending is ide. Sodium chloride. Let's start with sodium. Sodium is a metal. So we start the naming with its name, sodium, without a change, sodium. Chloride, because this compound is 2 atoms only, sodium and chlorine. So we will we will keep the root of the word chlorine, chlor, and add ide, chloride. And the name is sodium chloride. Calcium bromide. So we start with calcium, Ca. We'll start with the metal name, calcium. And then the bromine. We have here two only atoms, two types of atoms. So we will keep the root of bromine, brom, and then add ide, so calcium bromide. Magnesium and nitrogen. Magnesium is a metal, so we'll start the naming with magnesium, magnesium. And then nitrogen, we have two atoms, so we'll add ide, nitride. Hydroxide, iron, when it comes anywhere, we will add the ide because its name is hydroxide. Another example. FeCl2. FeCl2, this is iron and chloride. But which ion of iron? Iron has two ions, positive 2 and positive 3. This is iron 2. Why? Because it gives its 2 valency to the chlorine. So it will be ferrous chloride or iron 2 chloride. Iron 2 chloride. While FeCl3, so chlorine is 1 valence, so there is 1 here, and ferric is 3, so it iron 3 chloride. Iron 3 chloride. And so on. This is the rules of the naming. So when we have a compound with a compound ion which contains oxygen, the name will end in ate. So we have a compound, here we have calcium and a compound ion. This compound ion is called carbonate. Carbonate. Carbon 8. 8 is the suffix we add when we see oxygen in the compound ion. And the calcium is a metal, so that's why we start with calcium carbonate. Calcium carbonate. This is potassium and a compound ion with an oxygen. So we'll take the first atom in the root of the first atom in the compound, nitr 8, because we have oxygen here. This is magnesium, a metal, so we start, and a compound ion, sulfur, sulf 8, 8 because we have oxygen. Sodium, this example is very important. Why? Because here we have a metal, but it came in the end of the compound, but we still have to start with it. When we see a metal in our compound, okay, we have to talk, it's a sodium ethanoate, because this is the formula of ethane, and then there is oxygen, so ethanoate. The name of the same compound use prefixes to tell you the number of that particular atom in the molecule. And this number should follow the Latin numbering. What is the Latin numbering? So if we have 2, it's equal to di. 3 equal to the suffix tri. 4 tetra. 5 penta or pent. 6 is hex, and so on. 1 is mono. So 1 atom is monoatom. 2 atoms diatom. 3 atoms tri. 4 atoms tetra. 5 atoms pent. 6 atoms hexa. Okay. So for example, this is carbon monoxide. This is carbon. How many oxygen? Mono. 1 monoxide. Oxygen is named as oxide. But if it is CO2, this is carbon 2, but dioxide. Why? Because we have 2 oxygen. Dioxide. If we have SO2, S is sulfur. The name of the element is sulfur. And how many oxides? 2. Dioxide. N2O4. So we have how many nitrogen? We have 2 dinitrogen. 4 oxygen. So 4 is tetra. So tetroxide or tetroxide. And so on. So we'll start with the first name and we refer to the number of the atoms that exist in that name by one of the Latin numbering. 1, mono, 2, di, tri, tetra, penta, hexa. So the name of important mineral acids, they follow a logical system of naming, but are best simply learned at this stage, like sulfuric acid. We don't say dihydro sulfate. No, its name is sulfuric acid. Hydrochloric acid. Carbonic acid. So they are logically named, and we will learn these names by practice. Keep in your mind sulfuric acid and hydrochloric acid, nitric acid. These are the famous and common name for these mineral acids. Some have common name like water. We don't say dihydrogen oxide. We say water. NH3, the ammonia, and methane. This is a gas, methane gas. So they have common naming.